last day of our Congress. And also, we are going to have the last talk on our workshop for non-scientific skills. And we welcome Professor José Carlos Egues. He comes from the University of São Paulo at the São Carlos campus. He has a PhD in physics from the Ohio State University, postdocs in places like Universitat Basel, and he was visiting professor in many important scientific centers like the California State University. And so now he is at the Physics Institute at University of São Paulo in São Carlos. And he works with condensed matter, focusing on spin-dependent phenomena. And also, he is a member of the editor board of Physical Review B, and he organizes biannually a workshop called Meeting the Editors, where he brings editors from the PR journals to talk about scientific writing, the editorial process for these journals. And he's here to talk about a little bit the things on scientific writing and the editorial process. So thank you.
Okay. All right. Can you hear me? Thank you, Caroline, for the invitation. It's a pleasure to be here. This is actually the first time I'm giving this kind of talk. I usually organize it, but I never really presented this. So it's actually a very nice way for me to organize. And I thought it was not so hard because we've been doing this for some time now. So why am I interested in this? Well, when you hear someone talking about scientific writing, you have to have some credentials, right? Otherwise, why would you believe me? Why should I tell you how to write? Do I know how to write? That's the first question you have to ask someone who is, trying to tell you how to write. And usually, we don't know how to write. But I claim I write more or less okay, right? So, and I've been learning this for a long time. In fact, I would like to thank these people here, starting from actually my former PhD advisor, John Wilkins. That's actually the guy who was always very worried about presentations and writing and all that, and he was a little bit of a pain, but it was very nice actually to have someone push you to learn how to write and to worry about writing and presenting stuff. And it's hard, it's difficult. You have to work at it. We don't really know how to write even in Portuguese, our own language, right? So writing in English and presenting things in English is much harder for us. So I've been, as Caroline said, in the editorial board of PRB for 2 terms. It ended in 2013, and after that, I also got this prize, and that's the first time I'm actually proud of it. I can show this little symbol here. That means you're an outstanding referee, and that's actually a very important part of the scientific training, in my opinion, as well. You have to review papers. You have to be a referee. That's being part of the community. And it's difficult. And when you were young, when I was many years ago, I used to work very hard at refereeing papers, spending like a week, 2 weeks sometimes, doing all the calculations and sending this very long referee report. That's actually why I think people at APS ended up choosing me at some point to be part of the board, because I was being very active, a very active member of this refereeing process. And of course, some of you are quite young, maybe you don't have, haven't had any opportunity to write a paper, or maybe you have already. And if you did, maybe you had to interact with referees. And usually we hate them, right? Those are guys that you have this very nice, beautiful paper that you think it's perfect, and then the guy just trashes it. It's not a very pleasant experience, and a lot of times, and but we have to deal with this. So this is, we can talk about, that's not the focus of this, but there's a whole talk that we could present on dealing with referees, not in referee reports. And that's actually how this whole business started, this meet the editors that I'm going to briefly tell you about. So this is a brief outline. So I'm going to tell you a little bit about this meet the editors, the philosophy, what they've done over the years. And then I'll do some basics in the title and abstracts and things like this. And then, I'll talk about levels of approximations to writing a paper. And I'll end with a different topic, which has to do with, ending honorary authorship. But before I continue, let me thank these people here. Again, I mentioned my former advisor, but of course, Carrie Friedman, a very dear friend of mine. She was an editor for reviews of modern physics for about 20 years. This is in the old times, back in 80s and 90s, early 90s, where the editing process was completely different. So she would work with an author for like 6 months on a paper, on one of these long review papers that maybe you've had the opportunity to read. So editing, really working close with the authors on rewriting sentences and things that people don't do anymore. The editors don't do this anymore. This is the good old days. So she had a lot of experience with that. It was really a great pleasure and honor for me to get to know her. Fortunately, she passed away 2 years ago. There's also Celia Elliott from Urbana-Champaign. I learned a great deal with her. A lot of this stuff I'm going to show you here is just taken from her presentation. Also Lance Cooper, the prof at the University of Illinois. They are in the same department. There's also Saeed Habub, who is a PRL editor. Some of this stuff I'm going to show you is also taken from his presentation. This is Laura Green. You see her name coming up again and again here. She participated in many of these workshops. So I learned a great deal with all these people, and I'm very thankful for them. As I said, in an ever-going process where you have to be aware, and to learn stuff from good people. So, speaking of these outstanding referees, here, 15 of us. So you can see, maybe you identify one of the very first one. There's a program created in 2008 by the APS. So you have, one of your own here, Professor George Matsas, and also all these guys that you may know, Amir Caldeira from Campina, Sergio Zende, who is our Minister of Science and Technology. So this is, I think, a very important thing. We only have 15. So more recently, we had this Celia Antenedoro from PUC. I actually know her as well. So I think it's you should always strive for becoming an outstanding referee. I think that's a very good thing for you. You'll be a better person if you strive to do that, and then you understand the perspective of you should never write a report as a referee, a referee report that you would not like to get yourself. So you should not, sometimes you hate them when they say that our papers are not good, but sometimes when we write our own reports, referee reports, you tend to be some sort of, a bit acid, and that's not good. You should always think of yourself as receiving that report, whether you'd be happy with it or not, and you have to be fair. Anyway, so we have only 15 people in Brazil. Some of them are not even Brazilians. I think by the name you can tell. And so that's a small number. I think we should have many more in the future. So this series started in 2008 when I organized this big conference in Foz do Iguaçu. on spin-related phenomena, and PRL was turning 50 in 2008. So it just turned 60. It's getting old, it's becoming an old person. And then one of the editors at that time was Daniel Uko, was going around, and many of them were going around giving talks. And the title of the talk was PRL at 50. So I organized together with some of the other guys this. Within the conference, we had a morning tutorial. It was focused essentially for authors and referees. So it was called Tutorial for Authors and Referees. That's a very, if you've been to the American Physical Society meeting, March meeting, usually they have this tutorial there. So that's where you go to talk to the editors, to ask questions, to complain about the paper, and to also learn how to be a referee and how to write reports and things like that. So that's what we did. And Peter Adams, who was then the editor of PRB, Physical Review B, I mean, Condensed Matter, so that's the journal I mostly publish, and also PRL, which is more general. So they both came and gave presentations and talked to the students and also the researchers at the conference. So this was back in 2008. 2010, we repeated it. We were not very creative at that time, so I was essentially doing this. So this was the same announcement, which is the dates changed and also the year, right? So this time we had also Peter Adams, the late Peter Adams, who was the editor of PRB, and also Jon Komilev, who was the editor of PRL. So again, we repeated the same. This was within this school, this São Paulo School of Advanced Science, one of the first ones I organized in São Carlos. This school is a very important one that FAPESP sponsors. This was the 2012 edition, and then we started diversifying a bit more. So this was the first time we had, by then Molenkamp, Lawrence Molenkamp, had become the editor of Physical Review B. That's the guy, that's the group. So this is now a researcher. So PRB changed around 2008 to have a scientist as an editor. I mean, they're all scientists, the editors. They have PhDs, but Molenkamp is still an active scientist. So he works remotely in Germany, and he's the chief editor of PRB. That's the guy whose lab verified the topological insulator. The first two-dimensional topological insulators proposed by Shu-Zheng Chang and collaborators back in 2004 or 2005, was actually verified experimentally in his lab. Maybe some of you have heard of this. It's a new field in condensed matter called topological band structure. That's one of very hot topics. Back 2 years ago, the Nobel Prize was actually in this field, the field of topology in physics. So then we also had Jessica Thomas, who was then the editor of Physics. Physics is like similar to this perspective and also news and views in Nature. So whenever you publish a paper in one of the PR's physical review journals, sometimes your paper is picked so someone will write a longer, more accessible version of explaining to the community what you did. So that's what physics is. And then that was the first time Carol Friedman came, and then we added at that time this part here, scientific writing. So there was then very many lectures focused, as you can see here, and later on you'll see many links about this, where she taught us a lot, about English, about construction. It's a very interesting set of lectures. It's all online. It's in the web page of our institute. I'll point it to you later on. So then she actually stayed. At that time I was the head of our research commission at the institute, and I sort of created this concept of in-house editor. So she would stay at the institute for about 1 month, proofreading and editing and making comments and talking to the authors, the researchers who at that time had papers that were about to be submitted. So she would help them polish the paper. It was great. She would really like a dossier about the paper with all the comments, and you could discuss with her many issues. It was really wonderful having her. She's done that 3 times later on. And so this was the 2014 edition. So this time Celia came. This was Julie Kim from Physical Review B, Rapid Communication. And again, Carrie. So we had a special event in addition to the usual scientific writing. Celia actually told us how to write proposals. So that's actually becoming a very important thing. And she works at the University of Illinois at Urbana-Champaign, and she helps people there write their grants, grant proposals. That's an important thing to do, since we're in a very competitive environment these days. So again, she stayed there for another couple of days as an editor, in-house editor. So here we have the 2016 edition. And it was becoming bigger and bigger. That was the first time. Laura Green was then the president-elect of the American Physical Society. She's also very much involved with outreach in general, and also scientific writing. Maybe this was the first time Caroline participated on this workshop. So we diversified a bit the topics. So this guy is actually a medical doctor. He was an editor of the Journal of the American Medical Association. And he talked, as you can see, some of the tutorials and the lectures here was about academic misconduct. This fraud and all that. I'll flash some slide later on this. It's a big problem, this day. We have had, this kind of thing also in Brazil. It's everywhere. There are many reasons for that, and this was discussed and exemplified in many different ways. We also had a journalist from the Swiss NIAS Foundation, also Shomi Mitra from PRL, Julie again, Celia, so it was a very interesting workshop. And this was last year. So we had Lance Cooper, who came from the University of Illinois. We also had Priya, so she's from Switzerland, also in the medical sciences. And this is Henrik Rudolph from the Netherlands. So there were many different topics, and this was the first time we actually brought it over to other places, like IFUSP. So this actually happened at the main campus of the University of São Paulo. And also, in the week following this, this was like the October 1st and 2nd, and then on the 3rd and the 4th of October, we went to Natal with the same kind of program, except for Laura, who could not go. So this has been growing, and I already talked to Nathan, and we probably have this here at the Institute next year. It's been a great experience with knowing all these people and learning a lot. Every year we have different topics, and of course, if we bring it over here, we have to diversify in terms of the editors. People who are more in the fundamental, core stuff, and we have to contemplate also these areas. So stay tuned for later announcements about this. So let me start out then the actual plan of this. I'm going to advertise because I love this. This is actually how I got to know Carrie. I knew about this article. It's all online. You can download it later. It's wonderful. If I had to recommend one thing, is forget whatever I say. Just use this in your writing. This will make you a better writer. She had identified many interesting issues for native speakers and also non-native speakers. Misuse of words, constructions. We, as Brazilians, tend to use words that are used in Portuguese in a given context, and it doesn't quite work in English. Aspect, is one of them. Not the same, it's not used the same way. And we tend to use it as it, because it's so close to aspecto, but it's not the same. You have to, so there are many subtleties that she discusses. And in the set of lectures that she presented in São Carlos many years ago, and more recently in 2016, which was the last time she was there, she actually surveyed many papers, Brazilian papers, PRB, PRLs, PRCs, PRDs, a couple of them, maybe 20. And she tried to construct some kind of pattern to identify, our Brazilian most common mistakes. And even though the sample is small, looking and listening to her talk and looking at the data she presented, you can see that it is a pattern. Even though the sample is small, I would say you can generalize it easily because we're all Brazilians. We make sort of similar types of mistakes, and that's something that is very simple to correct if you're aware of it. And the same goes for when you speak English, right? It's like when people say consequence instead of consequence because you say sequence. So it's logic, right? But the English is not logical. So you have to be aware of this kind of thing. So this is a wonderful piece of writing. It's actually in one of the appendices of this Review of Modern Physics guideline, right? So and here I chose to start with the first part of it. She talks about sort of hints for non-native speakers, for everyone, not only foreigners. And then the second part, because she had this 20 years experience dealing with writers from all over the world, she will tell you like nice hints for foreigners, right? But let me start with for instance, just to see how it's a very light reading. It's very funny at times, and to illustrate that and actually already show you some important topic, which is choosing a title of your paper. You can see here that, we can read it later, but essentially it's like this, She says, she noticed that over many years that younger people, when you write a paper, you tend to write very long titles. And as she puts it here, it seems that you view your audience, the community, as like a big PhD committee that is judging, is going to judge you on what you write in your title. So you try to pack in a lot of info in the title because you want to cover everything, right? And that's what she detected. And then later on, the oldest people, when you get older, you tend to know your community more. You already worked with many people. People know you, have a reputation, hopefully a good reputation. And then you tend to be more relaxed, and your titles tend to be shorter and wittier, catchier. So you write something that will make people, want to read your paper. So usually when they were at Review of Modern Physics at the time, they would, ask people to change the title. So and of course in this article, she gives this table with some of the titles before and after, and later on you can read it, but you can see many of them are like 2 lines, 3 lines, and so on. And then think about it. This one, like, look, the diabolical nature of conical intersections of potential energy surfaces of this same symmetry. And then afterwards, it's much nicer, in my opinion. It's just diabolical conical intersection. It's, that's what it is. So, okay, so then, I find it's very nice. It's something to keep in mind when you're choosing titles. And of course, I check that with my own papers. I'm going to show you next is one of my very first papers. When I first, I think I was hired at USP in 1997. This was my first paper at USP. And you can see it's awful, right? It's like 2 pages. And I'm going to lay it to 2 lines of, I was very proud of this title. I said, wow, I have even a question mark well, it turns out that I find it not so nice these days. And also, later on, I will show you that this abstract also sucks a bit. It misses an important, ingredient here, namely the method that I use. Right? So you see it next. So this was when I was young, and then this was a bit later when I had to write some kind of perspective. I mean, in 2005, so 7 years later. It was not so old, but still. So I got a bit, I think, it's a very interesting title. Shorter, it captures the essence. If you read this perspective, you see that I'm talking about how you can take two electrons acting as qubits, put them in a box, do a measurement, and know whether they are, up, up, down, down, or whether they are up, down. Essentially that. So this is like, the total spin of a two electron is like its fingerprint or a spin print. That's also a word that I used throughout this perspective. Spin printing electrons, meaning, whether you, with the measurement, you can know what we call the parity of these two electrons, whether they're parallel or whether they are antiparallel, without destroying the whole thing, right? So it worked here, and I've been keeping this in mind. But it has to be natural. You don't have to try to look older now. Just keep this in mind, right? That sometimes it attracts, it makes people want to read your paper if it has a catchier title, right? But there are limits to that. So a couple of years ago, 2014, we had this nice paper. It's actually a very nice paper. It's on the Majorana stuff. I work on the Majorana, fermions also, with some collaborators and former students. And here we tried this one here. I mean, what we found out in this work was that if you had a chain, a so-called Kitaev chain, don't worry about it, some kind of 1D system, superconductor, P-type superconductor. And at the end of this chain, usually there appears this so-called Majorana bound state, like an excitation that is localized at the end of the chain. And this is a major area since 2012. It's like booming. Microsoft and many other agencies are putting a lot of money into this because of topological quantum computation. So in this article, we proposed to couple a quantum dot to a chain, and then we saw that the Majorana would leak out of the chain into the dot. And so we thought, well, why not something like Majorana is sneakily leaking? Sneakily is like surreptitiously leaking out. Sorrateiramente leaking out. We tried that, but it didn't make it, right? So they found it too, funny, I guess, or more of a joke. So it ended up like this. It's actually a very nice paper. It has about 70 or something, almost 80 citations. One of the basic and one of the new ideas in this business. So it's been actually verified experimentally, this leaking. And then you can ask yourself, what are the limits for a title? I mean, what should I keep in mind when I write a title? Well, the thing is, I learned this from Laura Green. I asked the question last time. I said, why? Why didn't they, I think you don't have any, the editors are no fun. They don't appreciate that. And then there's a reason, right? I mean, the titles must be witty, catchy, but they also are being funded by the government, right? And then you can imagine if you have, at some point, especially in the U.S., which is a mess these days, you can imagine, and also here, right? You can imagine people trashing universities and then say, see, that's what the taxpayers' money is being used for, to fund, this kind of, research, which is nonsense. So there's a point to that. You have to keep it, witty, catchy and all that, but still, with this, it has to be a serious business, right? So there's a whole talk by Celia on this. You can, on titles, just titles, right? So you can indulge yourself, binge watching all her talks. You can go to her site, and it's a very interesting site with many topics. So feel free to access that. It's in this, that's the link for this particular one. So writing an article, right? How many of you are actually have done actually research to the point that you have, how many of you have written an article before? Don't be shy. You have to speak louder and raise your hands very loud to be listened if you want to be successful in your career, right? So speak loud. Okay, not so many, right? So the basic rule is if you want to write a paper, you have to have something to write about. So you have to have a story. Even if you did the calculation, that's very common. When you're young, master's degree student, you don't quite know what you're doing. Usually we don't know what we're doing. I don't really know usually what I'm doing, but I have at least I know and don't know, right? But the problem with students sometimes is that you don't really know that you don't know stuff, right? So you have to actually learn how to learn that you don't know things, right? So doing a lot of calculation is not enough, right? You have to have, you have to publish. There's a reason for you to publish. You want people to read your paper. That's something to keep in mind. You want people to cite your papers. Just writing paper and then show your mom that I see that my mom loves my paper. That's not enough, right? She is not the one that's going to be in a committee to hire you. Hopefully not. I haven't seen this happening yet in this country, but anything is possible. So, but you have to strive to write good papers so the papers will be known by the community. You solve some important problems, and so you have to have a story to tell. That's the first thing. You finish the calculation, your advisor gave you a project if you're a master's degree student. You're just essentially doing something because your advisor wants it, right, done. Right? You don't quite know what it is to do research. Maybe you already did some, undergraduate research project with him, and so you have a better idea what you're doing. But towards the PhD, this should change. At the PhD level, you should be more actively participating in the project, even the writing of the project. That's what I do with my students. They have to participate actively in defining a project at the PhD level. At the master level, sometimes they don't have, ideas what it is that is important, and so you help them along. So the first thing is once you have a project, you did a calculation, you have to then talk to your advisor, and you have to have a story to tell, right? And this is something that I learned from my former advisor, which I keep in mind all the time. So that's a paper for me. That's another thing, two things that you should remember in this talk, and one is the paper by Carey. Download it, read it. And also this. I always keep this in mind when writing papers. Tell them what you're going to tell them, then tell them, and then tell them what you told them. That's a paper. So roughly speaking, this is just the introduction, the body of the paper, and the conclusion. It's always like that. Go check it out. Papers have to have this kind of structure, always. That's the mantra. Repeat it again and again. That's how it is. That's the only thing you have. And then, of course, that's the only thing you have to do. So in the next couple of slides, I'm going to elaborate on each one of these topics, the introduction, the body of the paper, and the conclusion, right? So something to remember. So let's start with the zeroth order. That's my attempt to make a joke here. So that's the zeroth order. What's the zeroth order approximation to writing a paper? That's also something that you should remember. I always use this. If you delete all the text, the main text paragraphs in a paper, and look at the figures and the captions, that should tell you the whole story. Of course, this is one of the disclaimers I had in my first slide was that this was sort of my own view based on experience that I learned also from other people and by writing my own papers. This is something that's it's a very good, thing to have in mind when you're writing a paper. So the first thing you can think about in writing a paper is to organize your figures. And of course, I could spend hours talking about figures here, literally, because the figures have to be nice. You have to spend a long time thinking of a sequence of figures that will tell your story, right? So this is essentially what I think it should be. It's one thing to remember, right? So maybe you know Calvin and Hobbes, Haroldo in Portuguese, I think. So he's the guy, right? Bill Patterson is the guy who created this kind of thing. So it's like a paper for me. This is actually emphasizing what I just said there. So they think, you know, I'm a genius, but I am a misunderstood genius. What is misunderstood about you? So that's this imaginary friend. You know. Well, nobody thinks I'm a genius, right? And you can, if you look at the figures, you can see that, you know, the figures is actually telling you something, right? So you see he has his shirt backwards, right? So the figures and the figure, many 1, 2, 3, and the captions should tell you the story. So that's the idea there. So let's go back and in this paper I showed you before, what are the figures there? So the figures are, so this paper hopefully you can understand what I'm telling you here. What I'm telling you in this paper is that if I have a barrier and I have a heterostructure like that, so the caption is, with this philosophy, the captions tend to be bigger, right? One line captions are useless. They don't tell you what the figure is about. So you have to describe the figure. So here I'm essentially doing that, but you can see in pictures that I have somehow the system here. I can have the ordinary quantum mechanics textbook of an electron going through a barrier. In this system, a barrier depends on the spin of the electron. Whether a barrier is a barrier or whether a barrier is actually a well will depend on the spin of the electron. That's why it's called spin-dependent transport. So if you manage to increase the barrier for one of the two constituents of the electron flow here, you can essentially block one of the components. That's a spin filter. I'm filtering the spin of the electrons that are going through the system. And then, of course, here I calculate the transmission coefficients. And if you look at it, I can show that, for a given, some particular values of the energy, the transmission can go to 0 for spin up. That's the filtering. And a third figure is actually the calculation of the current density. And of course, here is what I should put in the abstract, that I used the so-called Landauer-Bürger or a scattering approach to calculate the current. Well, that was the missing part. And we will see that, this next. So what are the rules for abstract? Right? So I'm switching gears now to abstract. And that's also Celia's great insight in pointing this out. So this is all and there's a whole talk on abstract. So it's the famous MMRC. An abstract should always have a motivation, methods in the sequence, results, and a summary or conclusion. Like a mini paper, if you want. All the essential information in a paper should be in the abstract, right? So those are the questions you should answer, right? What problems did you study and why is it important? That's sort of the motivation, right? What methods did you use? What were your principal results? What conclusions have you drawn from these results? So in this talk, in Celia's talk, she pretends she's like making a cake or actually seasoning some fish. You see a lot of fish in her talk. And so you have to mix all the ingredients. And so it's actually very entertaining talk, beautiful talk. She's great. And to answer these questions here, you depend on the size of the abstract in questions, because you can have, a couple of words or a few sentences, short abstracts, or you can have longer abstracts, or you can have like a full page abstract. So if you have a short abstract, you should have one sentence for each one of these things, right? So one sentence for motivation, one sentence for method, one sentence for results, one sentence for conclusion, roughly speaking. If you have a longer one, you can have several sentences for the motivation, several sentences for the method, several sentences for the results, several sentences perhaps for the conclusion, right? And of course, if it's a big, one page, say, abstract, you can even afford maybe one paragraph for each one of these things, right? So, but the main point that she emphasizes, and it's very important, is that you have to stick with these 4 ingredients: motivation, methods, results, and conclusion. Right? You should not drop any of them just because, oh, my abstract has to be short, that's why I'm going to drop the motivation. I'm going to drop. So you cannot do this. It's not, like when you're making a cake. You can drop the ingredients, but your cake is not going to be, ideal, as tasty as it would be, right? So you have to stick with it. And you should not also add more things that are superfluous, right? So just to make it larger. So you have to add meaningful things, right? Otherwise, it's useless, right? Another thing is you need time. You need time to write an abstract. You need time to come up with a nice title. You need time to write a paper. So usually, you should not expect to just whip something up quickly in the next hour. I mean, maybe if you're more experienced, you can do that. So it's easier. But even I, with many years of experience in that, I usually rewrite things many times because, you have to strive for, perfection. You have to be aware that it's difficult to write. So you have to, fresh look onto something that you wrote, 1 or 2 days before. It's always nice, or we can always ask someone to read it for you as well. But that's very important. Now, let's look at a very good abstract. That's a real abstract from PRL, right? So remember the MMRC, right? So that's the first sentence, the motivation, right? Look at that. That's beautiful, right? You can read it yourself. I'm not going to bother you with that. But it's essentially one line at the motivation, right? And then the second one is just the method. So they're using, it's an experimental paper, optical spectroscopy measurements combined with first principle calculation to back up whatever they're measuring, right? And then the third one is the results. One long sentence. I'm going to come back to long sentences later, but it's quite nice here. And then later on, you have the final sentence, right? This confirmed the bulk nature, blah, blah, blah. So that's a straightforward. If you keep this in mind, it's amazing, It makes your life a lot easier. You don't have to struggle. It's always like that, right? So you beef it up according to what you need, but it's simple. It's MMRC, right? So that's what it is there. So you can see it like that. It's nice different colors for highlighting different things. And mine, my abstract was missing the blue one here. So I didn't have any methods there. Shame on me. When I was young, you cannot blame it on young. Now, what about this abstract? So this is an excellent abstract, right? What about this one here? That's a witty abstract, right? Look at the title. The title is nice, too long, right? But anyway, can apparent superluminal neutrino speeds be explained as a quantum weak measurement? Maybe you remember a couple of years ago there was this thing about neutrinos, some measurement that went wrong somewhere, and then people were finding that neutrinos were traveling faster than the speed of light. Maybe some of you remember that. Turns out to be some problem with the equipment or something. And then these guys write this paper in the abstract, as you can see, it's probably not. So they're answering the question that you have in the title. Now, maybe you should not expect to get away with this kind of thing, because look who is the first author. So the first author is Berry, from the Sir Michael Berry, from the famous Berry phase. So he's also known from winning this Ig Nobel Prize many years ago, together with Andre Geim, who also got the Nobel Prize for graphene. and they got this Ig Nobel Prize in, I think, 99 or 2000 for levitating frogs. Maybe you remember, that was a Nature paper, actually. So, but of course, he's done so many great things, so I think that's how he could get away with this kind of thing. It's a published paper, right? Now, I was preparing this talk, and we were also finishing a paper that should appear on the archive soon, maybe next week. And I was reviewing this. It's a long abstract. So you can see, like, there's the motivation sentence there, and then there's the method here. And then I noticed, a couple lines down here, this is like results. But then here, you see here, it's highlighted here, it says, for concreteness, we perform a self-consistent calculation. And I said, oops, that's actually method, right? And then, these are results. So this is like lost in, so then you have to fix that. This was actually yesterday that I noticed that. And so we just have to rewrite it right here. So we moved, this sentence here. We don't have, we don't say that we're performing anything, and we just say it there already. So it's not like the end of the world or anything. It's not going to die because, of this. But it's just like trying to be more precise and conveying your message in a more articulate and straightforward manner, right? So we're fixing this. Now, higher order approximation. So I told you that, tell them what you're going to tell them that you told them. That's the general approach. That's what a paper is. And also that the figures plus the figure captions should tell the whole story, right? Now, that's like the zeroth order approximation. Now, what's the higher order approximation? They are the paragraphs, in my view, right? So how do you come up with paragraphs? Well, there's a whole, talk also in Celia's and web page on how to construct paragraphs, how to do this. And the common wisdom or actually the rules are that you should, whatever it is, remember the first, one of my second slides is like a sentence outline. Sentence outlines for talks, I usually find them not so useful because people tend to forget. I think you have to maybe give it very general. So I'm going to go from here to there. But if you just outline too much during a talk, I think it's not so useful. And as you go on, and people do this sometimes, whenever they switch from one topic to another, they show the old outline and say, oh, now I'm going to say this and that. So that's useful. I usually don't do that. But in papers and in many other things, when you're organizing projects or whatever, it's good to have a sentence outline. So what is a sentence outline? It's a way of organizing your ideas. You can actually start with just words, right? So you have to organize your ideas to write a paper. So one convenient thing and efficient way is to write a bunch of sentences, concise sentences, so that each one of these sentences will become like the main idea of a given paragraph. It's what they call controlling idea. Ideally, each paragraph has to have just one main idea that the paragraph is built upon or around that idea. So if you read a paragraph and there are like two different ideas, that you should break it up in two. So there are simple rules in general writing that if you keep in mind. So sometimes you're struggling to write a paragraph, and then you realize that you're actually trying to convey two main ideas in a single paragraph. So that you have to be aware of. So that's one way to, one approach to actually construct paragraphs. You write, for instance, if you're writing a PRL, maybe you have like 12 sentences, 13 sentences. That will become 13 paragraphs. So that's a way of, beefing up, putting flash on your around your figures, right? And you can be redundant. What's in the figure captions should also appear in the text. It's a very bad practice to write in the caption, see text, as explained in the text. No, explain in the caption as well. It's another chance to explaining something. It's okay to be redundant, right? So roughly speaking, that's the sequence here. You have many sentences. Each sentence will become a paragraph with a given topic or a given controlling idea, right? And you can, that's, as you grow older, you do things slightly different. Sometimes you can sketch your abstract beforehand so that you have some idea of how things. Is it too low or is it okay? You can change things, but one thing I usually do is sometimes I sketch the abstract a little bit, but later, after the paper is almost done, then you go back and you can write the abstract. It also helps you to highlight, to actually understand better. When it's a dynamical, it's a dynamic process, right? When you're writing a paper, you find out what the important aspects of the paper are, right? And then you say, I should highlight this more in the introduction or in the abstract. That's when you actually decide whether you have a physical review letters or you have a regular paper. It's during the writing process. At least for me, it tends to be like that. All of a sudden, you realize that, oh, this is very important. We made a breakthrough, and perhaps you should try something, better, like an express, communication. Of course, people these days send everything to PRL and then, get rejected big time because PRL's, acceptance rate is now close to 20%. So, that's why I have to send a lot more because it increases your chances to get accepted. That's not true, actually. You have to exercise, judgment, good judgment. You should read your paper and say, do I believe this is actually a physical review letters or not? It's a good thing to do. So here's some more specifics on what I just told you, right? So as I said, writing is not easy. We have worked very hard at it. And you have to be prepared to rewrite things many times. Now, the fundamental sentence of papers, is actually a sentence. And as I just mentioned earlier, you have to usually speak loud to be heard, right? And that's the equivalent in writing of using the active voice, right? As opposed to the passive voice. So you use, it's almost like an imperative, right? So the active voice is to be it's to be preferred for its greater impact. It's like that. Of course, in some cases, you need to use the passive voice. Usually when you're trying to, run for cover, right? You don't want to say it too stringent because you don't quite, it is like tentative. So then, in this case, some cases you can use the passive voice. It is supposed to be something like that, right? So you sort of take the blame off of the author when you use, if you're stating something that's too strong, you don't want to take the full responsibility, so you slightly running for cover, so then you use the passive voice. Of course, a paragraph consists of sentences assembled to make a single point, right? If you discover you have, as I said, 2 or more points in one paragraph, break it up, right? And then, of course, this main sentence that will become, the controlling idea of a paragraph, where should it appear? Well, there are 3 possibilities, right? Usually, that's the common wisdom in the field. The most conventional and easiest pattern for a scientific writer is to start with a sentence that gives the point to be made. So the most important thing right at the beginning, then you just build upon it, explaining it and beefing it up. You'll see a bit later some examples. And alternatively, the paragraph has a smooth introduction from the last paragraph, and then goes into an argument whose concluding sentence is the point of the paragraph. So this is another example where the topic sentence is actually the last sentence of the paragraph, but it also connecting naturally with the next paragraph. That's what I mentioned in the previous slide, that you have to have connectivity in the paragraph. So in this paper I mentioned by Carey Friedman, She outlined many interesting words that you can use when you're connecting paragraphs. That's also practice. So you check it out, and you see that they're natural, like in contrast, on the other hand, this kind of thing will smooth the text, and also the subject, right? You can end the sentence, the paragraph talking about something and then starting it with something else. You can, if you start with things like in contrast, for instance, right? So there are many technical and simple rules that if you follow, your paper will be much better, right? So the final point here is that really brilliant writers can place the point of a paragraph in its middle and still be clear. So this is my former advisor writing. Now he says, neither you nor I are that good. So if you find the main point in the middle of the paragraph, rewrite. So that's his advice. And I think it's a very good advice. So what is the structure of a lecture? So Caroline, how much time do I have? I tend to speak too much. So I don't have any more time. So then I can end anywhere. Okay. All right. So can I have maybe 5 minutes to wrap it up? So that's a structure of, say, a physical review letter, right? Title, abstract, and all that. The introduction is there. And of course, this is a talk by Said Hibou. You can download it there as well. He's giving very nice advice as well. So the introduction is actually very important. That's where you actually have to captivate, you have to attract your audience. And you can read this later. This is, it's going to be online, I suppose. And you have the, motivation for your research, the background information, justification why you're doing this, and a preview of key results, right? It's kind of like an abstract, right? So tell them what you're going to tell them. That's this. That's the introduction, right? And of course, here, it's very important because sometimes a lot of these PRLs these days, they tend to be boring papers because people sort of copy each other in a way. It's sort of the same style. The introduction is where the researcher can tell the story of the field in his perspective. It's your chance to tell the community your views. So try to be, original, creative. Right? It's not copying. Sometimes you just read papers in a given field. They all look the same in the introduction. They cite the same papers. Say there's no, there's nothing with like personality. It's important to have that. So that's essentially what it is, right? So what I just said. It's the sort of the introduction, like start with the big picture and then you go narrowing it down to your problem, right? Right here where you have this in this paper or in this letter. Right? And so on. I can just flip through this as one example where you have the big picture, and then you have the background information, narrowing of the focus to some specific example. This also from Lance Cooper's presentation. And then the however statement, justifying why it's important that you did what you did. And then it's kind of a very unusual introduction, in my opinion, this example. It's long, too long for a PRL, in my opinion. But, it happens sometimes. Usually you have, fewer paragraphs because usually people are packing up, a lot of things in PRLs, even though nowadays this has become a bit simpler because we have the supplemental material nowadays. So you can stick to the main important parts the research you did without too much technical details. Too many technical details. So one important thing that you have to keep in mind is you're going from the introduction to the conclusion, you should sort of follow a path without having too many diversions. And that's very easy to happen, right? You can start talking about something else along there. You have to be aware of that. So this whole talk here, he discusses that, right? It's very important. And that's also, as you see, it will happen even in a single sentence. You have diversions even within a single paragraph. You have to be aware of that. Sometimes you're just trying to talk about something that is not relevant, extraneous things things that are not relevant to what you're talking about. So that's why you need an outline, so you can know the sequence from one sentence to the next, and so on, that you end up with a nice logical structure for your paper. Now, there's also this nice reference in Whiteside's group, where he actually defines that the sentence outline is more than just a bunch of sentences put together. It's actually a whole set of is structured in a way that your data, your calculation all fit together. So you have to spend some time with the sentence outline. I do it to this day. Whenever I'm writing papers, you sit down and you do some brainstorming, thinking about what you do. It helps you organize your thoughts and to put it down later on. And then you just have to beef it up. So briefly, this is the usual, like level 1 structure of a scientific outline. Could be something like this: introduction, procedures, result, discussion, summary, where you have all these ingredients there, right? And then a level 2, if you want, with some more details, right? That's kind of like that. That could be one outline, right? Provide more detailed internal organization. So you have several levels of things. If you try to do this, right away, maybe you miss something. So take your time to think about what you're doing and organizing your thoughts, right? So you end up with. So again, in all what I'm showing you here, you can always identify this. Tell them what you're going to tell them the body, and tell them what you told them, right? Then there's, of course, the benefits of outline, which is actually very valuable, not only for writing papers, but also projects. Anything that you're doing, essentially, it's good to have an outline, right? For instance, if you're writing, big projects, sometimes it's good to have an outline because it helps you identify big portions of this, big chunks or portions of this project that you can, work separately and then make connections between them. It's a very simple thing that helps you organize your thoughts. I'm going to have to move faster now because I only have 5 minutes. My 5 minutes is over. But it's essentially this, right? Paragraph 1 has one idea, and then you have supporting example, references, and logical transition to the next idea. It's always like that. If you think of it like in a sort of mechanically, it makes your life a bit easier if you have a procedure, right? That's an example of an introduction without any paragraph. And then you can structure it like this, where you have, the topic, sentence, and then, the explanation and examples and all that. And then you also have the transition sentences at the end that connects the other paragraphs. So it's everything in life. It takes practice. You just have to, but of course, it's when you're learning English, right? You have to have some basic idea of the grammar a little bit, and then you have to practice, right? You should not just study grammar. Then you don't know, how to speak or the relevant stuff. So essentially, this is what I just said. Then once you have the sentences, a sentence outline, each sentence will become a paragraph where you exemplify your main idea and so on. And you explain and end up, at the end of the paragraph with some sentence that would help you go smoothly into the next sentence, right? Now, this can also happen, this diversion, right? You want to go from a start of a sentence to the end of a sentence like this, smoothly. You should avoid something like this. And there could be disruption. It's like when people start writing things and then they start to put commas everywhere, right? Explaining this and then this, and then concatenate many ideas. And that's like this divergence. It's this disruption to the narrative, flow. And for instance, like acronyms. I hate acronyms. There are some acronyms are like this, right? So this sort of, PL, photoluminescence, right? Single wall carbon nanotube. So one way to fix this is just to write out the acronyms, right, as much as possible. Some things you can, it's just part of the, scientific, Hall effect, quantum Hall effect. So those are things that people know. 2D, 2 dimensions. So, but many things people tend to. So the same sentence, if you write without acronyms, it's lighter, right? So and also avoid colloquial phrases and many unfamiliar words, jargons, and all that. So these are distractions along the way, and you have to avoid them. So there are a couple of examples also, long and unwieldy sentences that are too big. So if they're too big, and my rule is if you have to take if you have to take a deep breath or you read the sentence, or if you faint along the way because you cannot breathe because you're reading it, you have to break it up. So break it up. Those like 3 sentences, right? We tend to write long sentences in Portuguese. I guess it's because of a cultural background or something. So also this kind of sometimes you read something and you don't really know whether this here means what. Is this the Landau theory or is this symmetries of the Hamiltonian? So if you have doubts, speak it up, right? Just write it out. Then it is sometimes undefined, right? And also approaching, putting the verbs earlier to make it simpler. Use, passive as opposed to active verbs. Use active verbs as opposed to, passive voice, right? So there's some simple, fixes for things. Also, if you use like reasonable and sufficient, these are too vague, imprecise, and unnecessary. So you just remove them. That makes the paragraph or the sentences more straightforward and clean, right? Parallel structures as well, right? If you read the sentence here, review of the literature, design, so you're mixing construction. So if reviewing, constructing, taking, analyzing, that's a parallel structure. Very nice, very smooth, beautiful, right? So, so with that, I guess I can stop here and then end with just this last slide, which I think is very important. It has to do with academic misconduct. I want to cite this article here. This is Phil Greenland. He was here in 2016 for our workshop, and he gave like 3 wonderful lectures on fraud in academia, and especially in medical science. But one of the things that this editorial in Science is about is ending honorary authorship, which is this guy is a freeloader, right? The guy who didn't do anything and just is on the paper for some reason because his advisor wants to help him, or his your advisor maybe is his friend, or there is this kind of thing. So, and as a student, it's very hard for, or as young postdoc, it's very hard for you to tell your boss, well, this guy did nothing. So, he should not be in the paper. Sorry. So they discuss this kind of thing. They talk about there are the huge numbers of papers that are, show this kind of problem. Also, who, the order of the papers, or the order of the author should be, and so on. So, with that, I guess I will end right here. Thank you very much.
Thank you so much, Professor, for the important information, the tips. If anybody has a quick question.
I'd like to know your opinion about writing the mistakes and the errors we made, like during our project. For example, writing in the paper what we did and what didn't went right. For example, we tried this thing and this didn't go right, and write it out. Don't try this because of this and that. Writing the mistakes we've made.
Sorry, I missed the point at the beginning.
What's your opinion? Do you think we should put on the paper the mistakes we've made during the research?
Sure. I mean, you mean you got some? Usually, I guess what you mean is you had performed some experiments or some calculation and things didn't work, and people tend to show only what works. And of course, I think you have to be. That's part of being correct scientifically. Scientific integrity has to do with that. So it's important for the community to know what went wrong and whether it worked only under certain conditions. Sure, that's important, definitely.
But do you think referees will be fond of this idea? Why, when they are reading the paper, do you think they would
Well,
like
there are
accept this
ways,
kind of writing?
especially, for instance, suppose you're writing a PRL, right? The PRL has a long supplementary material. There's even PRBs, and all these papers now, you can have a supplemental material or supplementary material. And that's the place where you could put this kind of thing. You can discuss, so that it won't be in the main text, because it would be this sort of disruptive to some extent, unless it's something important, something that is wrong. It's like when people were measuring the Michelson and Morley experiment, right, to detect whether there was any difference in the speed of light through ether, right? There was no result. There was no difference, right? So then they came up with many things to explain why that would work, and it turns out that was completely wrong, right? We needed Einstein to say, well, c is constant and time is not absolute. So there are levels of whether it's something that is just technical, it's more of a curiosity, or something that will help someone reproduce your results. That could be elsewhere in the paper, or in not gaining some prominent position. Yeah.
Thank you.
Sure.
Any more questions?
Hi, do you think that long titles are acceptable for theses or dissertations?
I think that the rule is sort of general, but in thesis, more in the academic environment, I guess you can have witty, catchier title, but I think you have to exercise some caution there, right? Because there's a committee, but I think it's up to the author. Usually, that's what I tell my students, especially at the PhD level, because there are disagreements. I don't agree with my students, with whatever they write. I don't have to. It's their work. And that's part of being a PhD. Getting a doctor's degree means that you're becoming a scientist. So you're allowed to disagree with your advisor. You may think I'm wrong and I think I'm right, so we can discuss. And that's part of being, it's healthy to have this kind of discussion. So a thesis work is your work. The thesis is yours. I will proofread it, I will suggest a couple of things, maybe some changes. If I think something is completely wrong, like violating the second law of thermodynamics, then that's bad. But apart from that, science, you're allowed to be wrong, right? You can publish something and then later on, you redid the experiment, or you improved your approximation, include a couple more diagrams, and the result changed, and that's too bad. But that's, you just have to be honest. So in the case of a thesis, it's up to you. I think you have to exercise, you have to think about it, that towards the end of your PhD, you are going to be on your own. You cannot be relying on your advisor all the time. Hopefully, and that's usually what happens, by the end of your PhD, you think your advisor is dumb, hopefully, right? He gives you a lot of pointing wrong directions, right? That's you should listen to him with caution, right? That's how it is. If you believe your advisor all the way is God to you, then you should not, get your PhD. There has to be some disagreements, right? And you're going to be a scientist, and the scientists have to stand their grounds. You believe it, you defend yourself in front of the community. In the committee. So if it's a fair process, and usually you hope it is, and if you're good, you believe what you did, and unless someone you really messed up and you made a huge mistake, no one realized. But then when it's at this level, if the mistake or whatever error that you made is not so obvious, that's too bad, but there's nothing to do. But it's up to you. The title, it's your work. It's like your book, right? So you can, yeah.
I'm asking because sometimes people use the title of the thesis to in the paper. So
the same title.
Yeah.
Well, I don't usually like this sort of self-plagiarism. First of all, the thesis is one author. The paper has many authors, and you're sort of copying things. I don't do this. I don't advise people to do this kind of thing. I think it's, you have a chance to think of a better title for a paper, right? It doesn't have to copy. You have to, unlimited options. Once my former advisor many years ago told me, there are 10 ways to write the same paper. It's true. You can write the same paper in many different ways, right? Emphasizing different aspects. And if you give a given paper to an experienced guy to read, 10 different guys, they will all read and come up with the same main message. If the paper is written in a nice way and you have experience in reading a paper, you understand the main message. So I think copying is not a good idea. Plagiarism is bad, and that's actually a very bad practice, especially some Asian authors. It's part of their culture. Sort of they copy entire sentences, entire paragraphs from other papers, and they're actually proud. They think the author will be proud of it because they're using their and so their writings, right? So this is a bad practice, right? So.
I have one question. Do you have a preferred ordering when writing the sections of a new paper?
Do I have a preferred audience?
Ordering, like.
Yeah, so this is actually what you have to think about when you're choosing your journal, or whether you're writing for, even outside academia, right? Whether you're writing for FAPESP, magazine, or whether you're writing for a newspaper at the University of São Paulo, or whether you're writing for Physical Review Letters, Physical Review B, Physical Review C, whatever. You have to think of your audience. That's, when I said, do you have a story to tell? That's where you actually have to think about. Who is my, that's part of the thinking is, who is my audience? Who am I writing for? It's the same with a talk, right? When you're giving a talk, you have to think, what am I going to tell these guys? And one of the things that usually people do when they're giving technical talks is that technical talks, in my opinion, usually are very inefficient, because usually people come up here to show what they think is important. They don't want to teach you anything. And you usually respect people when they teach you something. It's always like that, right? In your committee, when you're in a thesis, defense, you have to think of it. Doesn't have to be something. Don't try to impress anyone with the diagrams, of fifth order or anything like that. Sometimes it's a simple thing that you have to explain in a way that people haven't thought about yet, that will make a whole difference. So when you're preparing a talk or making your sentence outline, you have to think about what the audience is. So PRL, one of the criteria that can get you in trouble is that it's not general enough. It may be correct, it may be important, but the readership of PRL is everyone in the community, right? So they publish papers in biophysics, high energy physics, cosmology, everything. So it's a journal that will be read by the vast majority of the community. So the first few paragraphs of the introduction should be general enough that even people doing whatever, bio stuff, condensed matter, they should be able to grasp the main points of the paper. So when you're writing your sentence outline or your introduction, you have to think of your audience for sure. Yeah.
Okay, I think we don't have much more time. We'll make like a 10 minutes break before the next talk. Okay.
So I just want to say one last thing, that you can go to the site here.
Yeah.
This is was when I was still at the head of the research commission. So all these are downloadable. I mean, these are the ones I told you about: Brazilian English, a nice scientific survey by Carrie Friedman, and many others. Are very interesting results there. Also from Celia.
Yeah.
This is all in the web page at Institute, right? All of these are there for you as well to check.
Yeah,
Thank you very much.
We can provide the slides online later if you don't mind. And thanks again, Professor.
Thank you.